Okay, hi everyone. Thanks for attending this talk. This is a pretty exciting topic. I'm really thrilled about it. This is Flink security enhancements. Who here has ever wished that Flink could talk to a Kerberos data source? Yeah, good, some hands, right on. You know that Flink has, I would say, some limited support for authentication today, quite limited, and I'm going to talk about that first. And then I'm going to talk through 3 new features that are coming, hopefully for Flink 1.2, along these lines. And that's Kerberos authentication support for data sources or connectors. That is what we call service level authorization, which means protecting your Flink cluster from the outside world. And third, transport security. All right, let's review what Flink can do today. Now, notwithstanding that you could have, application properties that are like passwords and stuff, that would be fine. There is a little bit of support today for Kerberos in Flink, and it kind of works like this. When you are using the yarn mode of Flink deployment today, let's say that you're using the CLI and you're going to do Flink run or yarn session. If you first do a kinit, right, which is how you log in to Kerberos, you will get yourself a Kerberos ticket. And then when you launch the cluster, what the CLI will do is it will go to HDFS and to HBase and will get what's called a delegation token. A delegation token is a way for the cluster itself to authenticate with HDFS later. So the CLI uses your Kerberos identity to obtain a delegation token and then hands that token to the cluster. And then the cluster can go and do work on your behalf using your delegation token. That's actually in Flink right now. And this is how a lot of Hadoop things work. Because really that stuff was developed for like MapReduce, so that you could launch a MapReduce job, you go and get tokens, and then MapReduce runs all day long, and it can go and get those files on your behalf. But there's a couple of huge problems with delegation tokens. Problem number 1 is it only works for Hadoop storage services, like HDFS, like HBase, but does not work for things like Kafka. Problem number 2 is that delegation tokens are time-bound. They expire in, at best, a week. So for a batch job, like in the era of MapReduce, that was probably cool. But in the era of continuous streaming applications, this is wholly insufficient. What we need is to give the cluster a credential that is sufficiently long-lived so that we can actually run a streaming job in perpetuity. When we looked out at what authentication support should be added to Flink, Kerberos stands out as the top of mind because while it's not an exhaustive authentication method, meaning there's still plenty of services or connectors you might use that do not support Kerberos today, Kerberos is something that's supported by a great many, including Kafka, including Zookeeper, and I'll talk in a minute how this goes beyond connectors, but also into other elements of how Flink state management works. So by adding native Kerberos support, we get to access a lot more connectors and backend state like Zookeeper. Now, I want to just make as plain as possible how this works. In a nutshell, when you launch a Flink cluster, whether into Yarn or into Mesos, you supply in the configuration a key tab. This key tab is a password file. Okay, this is who here has used Kerberos enough to say, I know what a key tab is? Okay, well, Kerberos is like a very complicated system, and no one really raises their hand about Kerberos. I don't raise my hand about Kerberos, and I'm writing Kerberos code. So that's an unfortunate thing. But the key tab is a stored password file. And they're often used as an alternative to like an interactive logon. So if you were using like Active Directory and like logging into Windows or something, you type your password like normal, right? But if you're a service account, meaning you're like not a human, but you're a service running in a cluster for an extended period of time, the system will have generated key tabs for you, and those are like secret password files that you have associated with the service. All right? So when we think about how a Flink cluster could be launched and give it a Kerberos identity that it can then use for services like this, we have to give that Flink cluster a key tab. When we do that, that's awesome, because then what happens is the entire Flink cluster has this key tab at its disposal whenever it reaches out to connectors or other external systems to authenticate with. In a minute, I'll show you how this is configured, and you'll see you basically supply this key tab. It gets pushed up into the cluster in a Mesos or Yarn specific way, and then it's available whenever these connections are made. I want to reiterate one point before I move on, okay? The key tab is available to the entire Flink cluster. It's not associated with an individual job. So when you know, sometimes when we think about like standalone mode or what have you, you've got a job manager and a bunch of task managers, and you run a bunch of different jobs over that, in that over time. That's not how you do this, because all those jobs that run in this environment have access to that same credential. So think of this as being the service account or credential for the cluster as a whole. When we started this sort of the analysis about what could be done here, it was pretty clear early on that it would not be possible to create a more granular form of authentication here, where each job could have its own key tab. That's unfortunately not possible, mostly because job code runs all over the place inside the Flink cluster, both in the job manager, in task managers. There's a class loader that loads the job code, and it runs like everywhere. So it was just not practical to isolate individual jobs within one cluster. So what you're hearing in this talk and other talks is that Flink is moving more into a mode where you run many Flink clusters, often concurrently, using a cluster manager like Mesos or Yarn, or Kubernetes, or any of the other myriad deployment approaches that Flink does or will support. So you think of it more like a Flink cluster is tied to a job. When I have a job that needs to be run, I spawn a Flink cluster to do it. I give it the credentials it needs to do that job, and that cluster expands and contracts as per the needs of the job. So, okay, this is great, right? We've got this key tab in place. Now we can access Kafka using Kerberos. We can access Zookeeper using Kerberos. And that's really cool because we can protect the state associated with the Flink cluster from malicious users. But there's like a teensy tiny problem here. When you think about the endpoints that are exposed in a Flink cluster, these little dark rectangles, I mean to depict server endpoints. And for example, the akka endpoints, akka is the control system that's used within Flink. These are like wide open. So if you know the port of this, you could submit a job to this cluster. I mean, that's awesome, right? Because you've given it your precious key tab, and then some other person comes in and submits a job and is running as you. So it's insufficient to just go and add new credentials into a cluster. We actually need to harden these endpoints. And that leads to the second thing, service level authorization. What we mean by this is just the initial authentication that is put in place on all of these server endpoints, so that not just anybody can talk to them, but you need to know something. You need to authenticate. What is coming is a very simple form of authentication that is protecting all of the various endpoints within a Flink cluster. It's based on a shared secret. So it's basically, in the configuration, it's called a cookie. It's a simple shared password that the client has to know, that all of the different parts of the cluster have to know, and that is how these components authenticate to one another. So this secret, depending on the deployment mode, is either something you configure or something that is generated. So in the yarn session, if you haven't specified one, it just generates one, and you can get it later when you use your CLI. It's sort of automatic. But you can also configure what the little password should be into your configuration file, and they're stored in a couple places. So that's really cool because we've protected these endpoints now, right? By protecting them, an arbitrary person can't just come in and submit a job. He gets like access denied. So now our key tab is safe thanks to this little secret. But someone could be listening on your network, right? Unfortunately, these secrets are in plain text. And the reason for that is because we're, at least for the ACA endpoint, which is arguably the most important endpoint here, because that's the control path, ACA supports relatively few authentication methods, and the so-called secret cookie is basically the only method that's supported in ACA to do that protection. And it's unfortunately transmitted in the clear. So for some users, that might be okay. Some Mesos environments have decently protected networks, but you could also probably wisely choose to use transport authentication. So here you take it to that third step, and you want to actually harden those links themselves with TLS. So the way that works is when you launch the cluster, you can supply TLS certificates, and TLS, SSL, they're kind of synonyms, but people say I shouldn't say SSL. I'm supposed to say TLS. So they're TLS certificates. You could generate a self-signed certificate, or if this is an environment where you have a certificate authority, you could generate a nice trusted certificate. And when you use the various Flink launch commands, you supply those certificates, and then all of the various connections are hardened. All right, so how about we actually see that? Okay, here's my Flink configuration file, and I'm going to launch a cluster with all of these knobs turned. I have enabled the service level authorization, and I've set the little shared secret here. This is a secret. I have supplied the key tab, which in my case was generated by, I'm using a Hadoop deployment from Ambari. Does anyone know what Ambari is? Ambari? I'm using, thanks. I'm using Ambari. Ambari creates a QA or smoke test user. For our little tests here, we'll be using that account. So I'm using the key tab that they generate for that purpose. And Ambari stores the key tabs in this directory, so there you go. And I've turned on the SSL settings. So I've generated a key store and a trust store. And when we deploy this cluster, both the CLI and the job manager and task manager all use all three of these files. Right? So whether you're deploying to Yarn or shortly Mesos, there's this notion of a sandbox, which is where files are staged into the cluster when the cluster is running. Yarn does it in an HDFS folder, and in Mesos it's in something different. And so all of these files, they actually get copied automatically into there. And they're associated with the user account that is launching this job. Okay, so you turn all those things on. now let's go ahead and actually run a yarn session. What I've just done the normal yarn session command here, and I've said I want one task manager, but I put a little extra argument on there to say I want to ship some files into that sandbox. In particular, I want to ship the certificates. That's something I'm hoping that can become implicit later. But when you look at these logs, it's a bit maybe boring, but you'll see, for example, there's stuff up front that's saying it's logging in as this Kerberos user with this key tab. So the entire job manager and task manager processes actually run with these key tabs sort of in place throughout the life of the job. Another thing to notice in these logs is that ACA has come up, and here you can see on this side here, you can see the ACA connection string has the word SSL in it because the ACA endpoint is now secure. Okay, so good news, I have a task manager up. Now let's actually run a Kafka job. I'm going to create a Kafka topic real quick. Okay. Oh, evidently my Kafka is not happy. First thing I did is I configured Kafka for, okay, well this demo might not work. I'm not anxious to debug a Kafka problem. But you can see I've actually brought up Kafka. Sorry for the smallness of this text, but you can see that Sazzle here, which is Kerberos effectively, is enabled on Kafka. And then when I launch my my Flink job, here, can everyone see this down there? When I launch the Flink job, I'm going to specify some extra parameters. I'm going to show you what the contents of this environment variable are here. I see Kafka client props. Basically, I'm launching the stock example that is built into Flink. Here, this is just a simple Kafka consumer. And this consumer understands various properties that you can see here. Normally, when you do anything with the Kafka connectors in Flink, you specify things like what's the Kafka bootstrap server list, what's the Zookeeper connection, what's your Kafka consumer group. But there's actually other settings you can specify to turn on Kerberos. So you say to Kafka, I want to use the Sazzle plaintext security protocol, and that means turn on Kerberos. Okay? And what's really cool about this is, yes, you have to tell the connector I want to use Kerberos, but it automatically uses the key tab that was provided. So unlike, there were hacks kind of in the community before where you could kind of finagle your way into getting this to work by deploying key tabs by hand. This system is totally automated and does work in the Yarn and Mesos modes. So you just launch your cluster, the key tabs are shipped up, they're activated as part of the cluster, and then things like this just work. So while we've tested primarily Kafka, because that was a use case we cared about, this is something that I do think will work with Elasticsearch and other connectors that are Kerberized. So do tell if that's not the case. Like if you find that to be otherwise. We talked a little bit about those settings. They bear on all of the little green parts. You saw these already. When is this happening? Well, there are PRs open for most of this already. We're kind of going through that process of getting them into master. We think that will happen for the next version of Flink, which is 1.2. This has been done primarily by Dell EMC. We're a company that cares a lot about enterprise-grade software and security and storage. We've got lots of cool storage products that use Kerberos, and so we love Flink. We want to see them work well together, and that has led to these contributions. There are some JIRAs that you can track if you take an interest in this. There are definitely follow-up items to do as we learn more about how this is really working and where it could use more polish. So we could use your help down the road. Thanks again for your time, and I'll now take some questions. Hi. I mean you. Bad things. I would say that the longevity of these credentials should be on a scale at which you'd be willing to use save points. So while a week expiries, probably not, right? If your key tab expires in a year or your certificate expires in a year, there you should use the save point mechanisms of Flink to actually suspend your job, make those changes, and then bring your job up from a save point. Hi.
So I agree with the usual that about one which is also inherently linked to security, right? Because they're for years. Have you considered things like vault or something that can just generate some stuff on the fly?
I think that is a great idea. I think you just said use a secret manager like Vault to obtain these on a more sort of granular and more frequently. I think even within the life of a job, you would want that, because I think much of what is going on in Flink now is designing for streaming, right? So we design for continuous operation, design for that long-running job. So I would say that what we should really be doing is looking at how to do rotation even within the life of the cluster. And it's something that definitely, I think, would be a great contribution to build a more of a plug-in model where you could plug in a secret manager. Like, for example, Mesos has a new cool secrets manager store of its own that actually uses Vault under the hood with its own plug-in mechanism. So one can imagine plugging these things in at different levels to get those kinds of effects. Yeah, but I totally agree with you, and Vault is a really cool product. Anything else? Oh, hi.
Yeah, I have two questions, in fact. So the first one would be, did you look into certificates as an alternative way for authentication, similar to what Kafka would do, I guess?
Depends on which you mean. Do you mean for the service level authorization, or do you mean for connectors?
As an alternative to Kerberos, for example.
Oh.
Because you could use the common name in the certificate, for example, as your identity.
Well, I don't think there's nothing wrong with that. I would be curious about what specific connectors or data sources you would gain access to with that approach.
Okay. And the second thing I would like to ask is, it looks fairly similar to what Spark does with security. So I was wondering, this akka pre-shared secret thing, do you think it would make sense to approach akka to ask them if they would come up with something smarter than this? Because I found this extremely ugly to deploy, a plain text password everywhere.
Yeah, I totally agree with you. The extensibility in akka with respect to transports is there, but very sort of simplistic. It's kind of a wholesale replacement one needs to do, where the netty transport, which is the default transport in akka, supports SSL and supports this little secret, but has no extensibility within that. So you kind of have to do a wholesale replacement of the transport if you wanted to go and get something else in place. But they're cognizant, for sure, that secret is kind of silly, because I don't want to say it's deprecated, but it's certainly maligned in the community. So I agree with you, and I would love to see that improve.
Hi. So you're always going to have the shared secret as well as TLS certificates, or can you use the certificates for authorization authentication as well?
I know that it is like overly complicated in that sense, that there's all these secrets running around. There is the secret to get service level authorization, which is a simple secret, and then there's these transport security certificates. It's really ACA that was caused this to occur, because where other endpoints in Flink are wholly under Flink control. Like, for example, Flink has a whole data path that uses Netty and is really awesome and could be changed completely. ACA is fairly fixed in what it can do. And one thing that it cannot do is client authentication with certificates. And so since the purpose of service level authorization is to actually authenticate the client, certificates was not a viable option.
Okay, thank you.
This secret for authentication, this is really ugly. So did you try also, other than ACA, actually use some network level security to do certificate-based authentication between the servers without, bothering the ACA framework? You get the same end result.
Well, I couldn't think of it. I don't know of any better solution right now, given the ACA dependency that exists. That could change, or ACA could evolve. But aside from that, if you wanted to, shall we say, move the problem down into the cluster manager, and maybe you're alluding to that.
Yeah.
For example, in Mesos, there's network virtualization there, so that each different task gets its own sort of virtualized network space. That could be another way to approach
add
it.
on IPsec or other certification on that.
And I'll just say that you can turn this service level authorization off if you are using, say, a virtual networking capability in something like Mesos. Stefan, you have a question?
Yeah. So the whole problem really seems to be that for some reason ACA didn't add a plug-in point for SSL in its remote Netty transport, right? If that were there, then you could use the same certificate infrastructure you use for Flink's data plane for ACA's remote network communication as well. So just a wild thought, how hard would it be to actually fork that part of the ACA project, just the Netty remote transport plane? Because it doesn't really have, you probably don't even have to do a lot. The way that Netty is built, that you built this, you have these pipeline handler factories, you really just need to inject one or two handlers in front of all the others.
I'm totally with you.
That doesn't sound like it's too much of a thing.
What I would say is it's client authentication that we're trying to add here. So if you could do client certificate authentication, that's what you want. How do you get it into ACA? I bet you're only 100 or 200 lines away, or it's something very small. As you say, it's not a big deal, but it's not really extensible today. So yeah, if you're willing to fork ACA, for sure.
You don't have to fork ACA as a whole, right? I mean, ACA, you can plug in different remote transports, just that everybody basically just uses the same remote transport, which is the Netty-based remote transport that is shipped with it. You could just create a Flink-flavored Netty remote transport for ACA.
Yes.
Use that. You can plug it in that, and if that is really a 200-line diff towards the one that comes with ACA.
No, I'm sorry. I don't want to misspeak. Replacing ACA's transport with your own transport is an extension point that's there now, can be done. But the amount of code in the Netty transport is vast and is not public. Meaning it's not intended for reuse. So the Netty transport in ACA is monolithic. If you want to replace it with your own transport that does have, say, client authentication, definitely we could do that, but it's a lot more code.
All right.
Yeah. If you want to fork ACA, you could change that,
Okay.
or something more than that.
Maybe fork a subset.
Yeah. Any other questions? No. Well, thanks again for attending.
Thank you.